Hello, knowledge seekers. Welcome to Remedial Tutorial Academy. In this video, you will learn to classify real numbers. Much of this should be a review for you, but we want to make sure that you understand the words to describe different types of real numbers. We will go over real numbers that include rational and irrational numbers. And within the rational numbers, we have integers, whole numbers, and natural numbers. Remember to write the notes down, including the examples, and to make note of any questions you still have. The notes page should be in your notes section. And if at any point the video is going too quickly, remember that you can pause the video to write down what's on the screen, or you can even replay parts of the video. We'll start from the inside out. We'll talk about natural numbers first. Natural numbers are your counting numbers. Those are 1, 2, 3, 4, etc. And that keeps going. Those are the first numbers you learn as a child. Next, we have whole numbers. Whole numbers are all of the counting numbers and 0. So we have 0, 1, 2, 3, 4, etc. Next, we have integers. Integers include counting numbers, their opposites, and 0. Recall that opposites are like -4 and +4. They're the same distance from 0, but one is negative and one is positive. So when we talk about integers, we're including -1,000,000, 100, -7, and all of the positives. We have -4, 3, -2, 1, 0, 1, 2, 3, 4, all the way into the thousands and millions and billions. All of the numbers that we've talked about so far have been subsets of rational numbers. This means that they're included in rational numbers. Rational numbers represented by the letter Q are any numbers that can be written as a fraction. The numbers that we've talked about, the integers, the whole numbers, and the natural numbers, are all over the denominator 1. So 3 is the same thing as 3 over 1. And -3 is the same thing as -3 over 1. So everything we've talked about so far has been a rational number. Rational numbers include repeating decimals and decimals that terminate. What this means is, if we have the number 0.6 repeating, since that could actually be written as the fraction 2/3, it is in fact a rational number. Any repeating decimal and any number that terminates or ends eventually, even if it's a long decimal with many digits, are still rational numbers. I'm going to write a few more examples of rational numbers for you. I wrote them over here on the left. We have 0.729, which is 729 thousandth, and therefore we could write it over 1,000. And any decimal that ends like this will be a rational number. We have -5/7, which if you did it out on a calculator, it would be 0.7142857, 142,857, 142,857, but again, that repeats. And we know right here that it can be written as a fraction. Fraction, -1.6, and 1 3/8. Those are all rational numbers. Now, a final thought about rational numbers. When we say it can be written as a fraction, we mean a fraction where the denominator is not 0. This brings us to irrational numbers. Irrational numbers are real numbers that are not rational. In other words, they cannot be written as a fraction where the denominator is not 0. And in the decimal form, the decimal does not terminate or end, and it does not repeat. Some examples include the square root of 2, the square root of 5, the infamous pi, which we know goes on forever and ever and ever. And you can try to memorize as many digits as you like. The square root of any number that's not a perfect square will be an irrational number. So all of these rational numbers and irrational numbers make up the set of real numbers, which is the focus of what we use in everyday life, and so far in all of your math classes. Notice that a lot of numbers fall into multiple categories. For example, all of the whole numbers are also integers, and they're also rational numbers, and they're also real numbers. So anything that's inside of another bubble is included in that. Now that we have all these classifications, we should be able to take any number that we're given and list the categories that it falls into. For example, -7. Think about which categories that falls into, and do the same for the next two. Pause the video to test yourself, and then I'll write the answers. -7 is an integer, it's rational, and it's real. The square root of 40 is irrational. Don't let this I confuse you. And real. And 9/4 is rational and real. The square root of 9 we know is 3, because 3 times 3 equals 9. But what about the square root of -9? We know that 3 times 3 equals 9, and -3 times -3 also equals 9. So therefore, we can never have a number time itself that equals -9. So there isn't the square root of 9 in our real numbers. And we actually write it instead as 3i. That's an imaginary number. You don't have to worry about it for now. Thanks so much for watching. Until next time, peace. Don't forget to subscribe and share for your friends and classmates.